For example 62, we're going to figure out what the summation needs to look like that you would be using as your formula, starting with 1, going to some stopping number, and then we're going to figure out what that formula needs to look like. I like to look at the last term, And the pattern is usually pretty evident from the last term's formation, as long as that last term hasn't been calculated. It's been left as 2 times 12 minus 1. And so that's going to give you an idea of what this pattern looks like from one term to the next. 2 times 12 minus 1. Okay, so if you assume that the 12 is in that K position, that's going to change from the first term to the second term to the third term and so on and so forth, that's what's going to go right there for your K. All right, so it looks like K goes all the way to 12 in that case. Put a question mark here because we're not quite sure. Okay, so if that's what our formula assumption is, we're going to write our formula as 2 times K minus 1. Man, I can't do this very well. 2 times K minus 1. That's my thought. I'm pretty sure that's right, but we're going to test it out just to see how it works. So if that's true, and that's when K is equal to 12, back in the beginning, if K is equal to 1, is that going to work? Is that going to give you that first term? Using that formula where K is equal to 1, I think my formula is 2 times K minus 1. All right, so let's use this formula and start at the beginning where K is equal to 1. So plug in 1 for K. 2 times 1 equals 2 minus 1 equals 1. And sure enough, we got the first term in our series. The next term should be a 3, right? We're going to see if we get a 3. That's the second term. The second term is when K equals 2. So if K equals 2, 2 times 2 minus 1 equals 3. We got it. Let's do it one more time. What happens when K equals 3 for my third term? 2 times 3 minus 1 equals 5. So I've checked it for the first 3 terms. I'm convinced now that I've got the appropriate formula, and K goes all the way from 1 to 12. No, sorry, I have a dog in the background. All right, express the sum using summation notation. So we've got similar kind of setup here, but now we've got the irrational e that we're working with. And so we want to figure out what our pattern is. How do you go from one term to the next? And it's much simpler if you jump to the end, because that ending term is usually going to tell you what the pattern should look like. N divided by e to the n, right? But when you write this with summation notation, we're going to go from K equal to 1 all the way to where we need to stop. And that is the question. And in this particular case, we don't stop in anywhere in particular. We go all the way to this arbitrary value of whatever we want n to be. Okay? So if we try just using the formula as it states, n divided by e to the n, is that going to work? Is that going to give you the first few terms if we check? So let's check that formula for when n is equal to 1. Oh, you know what? I need to change something here. This is not going to make any sense. We want to use K. Okay? Because n is where you want to stop. Okay? So K is going to be the variable that we're going to be changing each time we repeat this process. The first iteration is when K is equal to 1. If K is equal to 1, we should get our first term in our lineup. If K is equal to 1 in that formula, we get 1 on top divided by e to the 1 on the bottom, and it does give you 1 divided by e. The second iteration is when now K is equal to 2. You repeat the same formula, this time K equals 2. If you replace the K with the number 2, you get 2 on top and e squared on the bottom. So we got it. Here's where K equals 3. You should have a 3 on top divided by e to the third, and that's what you get if you replace the K with the number 3. So this formula works. Next example, number 70, find the sum of the sequence. Okay, so now we do need those formulas from your formula sheet. We didn't need them until now. We're just adding up the value 8, 50 times. So if you think about it, you're adding up 8 50 times. I don't feel like adding up the number 8 50 times. So luckily we have a formula, or if we thought about it, we could figure it out ourselves. Without a formula, you've got 58s in a line that you're adding together. The way to figure out this total sum is going to be 50 times 8, or how about 400? Number 72, find the sum of the sequence. All right, so I want you to realize that the negative k, can be written as negative 1 times k. Which means we can pull out that negative 1 into the front of the summation, and now we've got something that looks just like the formula for the sum of k. The sum of k, according to your formula sheet, says if you added up k 24 times, you would end up using the formula that says take the value of n, which in our case is 24, times 24 plus 1 divided by 2. So 24 times 25 divided by 2 is what I'm working out here. Grab your calculators. Negative 300. The sum of the sequence in number 80. So we want to see if this matches any of our formulas that we have available to us from 11.1 on our formula sheet. And the last one down under the sum of sequences, there's 4 total. That fourth one is the sum of k cubed. And so this says the sum of k cubed, I'm going to write out the formula in general. The sum of k cubed as k goes from 1 to n is equal to n times n plus 1 over 2 quantity squared. All right, now this is going to be used to answer this question, but we have to do a little bit of work. We can't just use it and be done, because as you notice that the sum that we're evaluating right now starts at 4. That's different than 1, and so this is not going to be just a straight use the formula, be done with it. Okay, if it was k goes from k equals 1 to 24, it would be very easy to find that out. Okay, if it was k equals 1 to 24, we would just use the formula for when k equals 24 and work out all the arithmetic, and we're done. Because the formula, once again, starts at 1. But the problem we have starts at 4. So let me write out the first few terms so you understand what's going on. This would be, let's leave some space. This would be, what, 4 cubed plus 5 cubed plus 6 cubed, and so on and so forth, all the way down to 24 to the third power. So this would take you some time. If you wanted to type this into your calculator, you could. It would take you about 10 times as long as using a formula. Okay? And that's assuming you don't make any mistakes. There's lots of places to make a mistake on that. So the thing you need to consider here is, well, what's being left out? What am I not including? Well, you're leaving out 1 cubed, 2 cubed, and 3 cubed. All right, so those are the values, those are the terms that are not included in your answer. If they were included in your answer, this would be great. You would just use the formula, k goes from 1 to 24, and you're done, okay? So why don't we go ahead and do that? Even though it doesn't say to, let's go ahead and do that. So let's use the formula. K goes from 1 to 24, okay? So I'm gonna erase this n. I'm gonna write in there what it's supposed to be, 24. And according to this formula, when k goes from 1 to 24, I'm gonna get 24 times 24 plus 1 divided by 2 quantity squared. All right, we're gonna start with this and see what happens. So what is that? 12 times 25 again, that's 300. We square it, let's see, 300 squared is about 90,000. And so that would be the sum if we did go from 1 all the way to 24. But we didn't, but we're not supposed to. We're supposed to leave off a few terms. And so how do you want to handle that? Well, we could subtract what those terms added up to. 27 plus 8 is 35, plus 1 is 36. So you could subtract 36 from this, and that would give you the answer that you need, 89,964. All right, so that's one way of getting that answer, which is perfectly acceptable. Here's another approach you might want to consider. We could take the sum as k goes from 1 to 24 of k cubed, and we could subtract the sum as k goes from 1 to how far? How far should we take the subtraction piece? Well, the subtraction piece needs to be done for the first term, let me emphasize, the first term, the second term, and the third term, and then that's it. So we want to subtract all the way through the third term, okay? So we're going to use the formula for the first summation, which is what we did up above. We got 24 times 25 over 2 squared, okay? And then we can subtract. Now we're going to use the formula all over again. This time we stop at 3, okay? So n is 3. So 3 times 4 divided by 2 quantities squared. And the first piece would give you the 90,000. The second piece, if you worked it out, would give you, let's see, 4 divided by 2 equals 2. 2 times 3 is 6. 6 squared is 36. And that would give you the same exact answer. Okay, so I'm showing you both approaches. Obviously, you're free to do it whichever way you like. The disadvantage to doing it the first way, this is the first way, the disadvantage to just finding that sum of terms you don't want to include is what happens if that's more than just a few terms. You know, what if your problem went from k equals 400 to 500? Would you really want to sit there and figure out how much the first 399 terms added up to? So this is the advantage now in the second approach of using that formula twice and understanding how far to go in your subtraction. And then understanding that you want to go through the third term if your answer picks up at the fourth term. Okay, you stop at the prior term when you're subtracting those values from your big answer, from your big sum. So you might want to watch that part again. I know this was a long video. I apologize for that. But you might want to watch that last example one more time just so that you've got a good understanding.